Web3 is bringing together a number of technologies that will allow us to automate many business processes. But automation in a multi-party, dynamic environment involves complexity and variability. Smart contracts and AI will be two of the most important building blocks of our increasingly automated future. Welcome to W3B TAlks, an ongoing exploration of the impact of Web3 and blockchain technologies on business, government, and society. My name's Doug Heinzman. I'm the Chief Catalyst of the Blockchain Research Institute. And we have today the exact right person to help us understand how both smart contracts and AI are changing the way that we think about process automation. We're joined by Florian Herzog in Zurich, Switzerland. Florian is the co-founder and CTO of DGTAL and the founder and chairman of Deon Digital. DGTAL is an insurtech company bringing AI and automation to the insurance industry, and Deon Digital delivers a transaction lifecycle and analytics platform for automating management of complex business processes. Florian was also a longtime researcher and lecturer at ETH Zurich. ETH Zurich, also known as the Swiss Federal Institute of Technology, is also where he earned his PhD in engineering, mathematics, and finance. Welcome to the podcast, Florian. How are you?
Hello, Doug. It's a pleasure to be with you.
Yeah, thanks so much for joining us. I've been wanting to talk about this topic for an awful long time. A lot of at the core of Web3's potential is this idea that multiple entities can coordinate their activities, and that a lot of the activities, the processes that go on, can be automated because we have these new constructs that allow logic to be processed in a way that all the parties can have confidence in. And this is a huge amount of potential. And so, as I said in the introduction, there's kind of two big topics, and you happen to be great on both these topics that I really want to kind of talk to. So the first is smart contracts. Smart contracts are the code that can live on a blockchain and can have certain kind of basic logic in it, right? The if, when, then logic kind of construct. And that can bind together these various different processes, and it can do all kinds of, interesting basic sort of things. But most of the stuff that most of us are familiar with are moving, funds or assets from one wallet to another wallet. But smart contracts are really about a lot more than that. Am I wrong on that? I mean, give me some examples.
No, you're not wrong. No, you're not wrong. A contract, regardless if it's a smart contract, but a contract is a construct between two parties that agree to exchange economic resources. One resource is usually money, and the other resource is maybe an asset if it's in a blockchain where you move money against an asset. But in the real world, it's, for example, I provide a service. I talk to you and you pay me. So the economic exchange of economic resources is my resource time versus you paying me. Of course, you don't pay me here. And the smart contract concept is that this gets automated between two parties in a way that they have certainty on the exchange of economic resources. And that entails, what are the rules? If you do that, then you shall do that. If I talk to you and I provide you 40 minutes of my time, and your podcast is being on the web, then 30 days later, you ought to pay me. And instead of putting this in just paper, we put this in a machine-readable form that, for example, your payment gets automatically done. Either it's on a blockchain, so you pay me in Ether, or you pay me through your bank account. And the machine, for example, if you automate it, can measure that. If your podcast goes live on the webpage of the Blockchain Research Institute, there's a clear digital readable evidence, an event, and then 30 days later, the robot you built paid me on my bank account in Switzerland. Hopefully not Credit Suisse, but any other bank. And this shows in this very, very simple example that smart contracts is the automation of business exchanges between two parties, and if it's on a blockchain or other forms, evidence that we made this agreement. So I agreed to talk to you for a certain amount of time, and you agreed to pay me. Of course, you don't pay me here. And later, you don't need to pay me. I'm happy to talk to you. and later, the machine can measure, for example, that I fulfilled my thing, the podcast was published, and now you need to fulfill your part. And in a classic blockchain world, everything lives on the same platform. In reality, it doesn't. In reality, you have a bank in Canada, I have a bank in Switzerland, and you have your web page where you post your podcast or your webcast.
Right. Okay. So, but beyond the case that we've just been describing, which is a very powerful case, the idea that you release funds to the appropriate parties when some sort of condition is met, that's a very, very powerful use case, because the way that we've been doing that for, most of the last couple hundred years involves a whole bunch of intermediaries and a lot of time and a lot of friction, a lot of reneging threats, yes, and all those sorts of things. But, beyond that use case, I mean, you can use this thing to register assets like a vehicle or property, or send notification of the arrival of a shipment, or an yes, alert about an inventory condition, or processing an IoT trigger. I mean, there's a ton of stuff that you can do with this. And the kind of where I want to go with this is that it's got this great potential, but then we run into what I like to think of as a context problem, that as we're using it to coordinate the activities of various different kinds of participants inside of a supply chain, for example, that depending on the jurisdiction, depending on the native language, depending on the legal, history and culture, depending on the industry that they're in, there's a different understanding about what even words mean, and different assumptions about the background, legal jurisdictional context for that contract. And it's always concerned me that the lack of kind of agreement and precision in these things will undermine their potential. And so how do we deal with this idea that contracts in different contexts to different people in different industries can mean different things?
I mean, first of all, you have to distinguish between legal subtleties, like the interpretation on the execution of a contract under English law or Canadian law vis-a-vis European continental law. Contracts tend to be, contracts actually a good space of sort of the legal domain to be automated, because contract is the exchange of resources, of economic resources. And the understanding what a contract is fairly common, regardless if it's English common law or continental law or even Japanese law. I think that's quite common. And what you can automate is the process of exchange, the process how you sign something, how you measure the events, and so on. You may not be automate subtle legal meanings such as what is force majeure and so on. But how many contracts actually go to court and this type of things are discussed? This will be always legal or lawyers' matters. But the vast majority of commercial contracts is about efficiently executing business transactions. We make a business transaction, the business transaction has conditions. It is important that we agree on sort of the conditions. You sign it, I sign it, that there's clear proof of that we did that. And then, and this is to the point what you said before, that the actual execution of the transaction can be thoroughly measured. So I have the guarantee that, for example, you provide a service and you have the guarantee that I pay. But also we are moving to a world where ever more things become digital, and we have ever more machines being able to do things humans only did before, like reading a document or asking a question on a document or extracting key data from a document. That's what we do on the insurance side. And for example, because in the insurance, to give you another example, I have an insurance policy and I go to my insurance and said, I have a claim. I have a home insurance, my window broke. And I write you a letter and attach you a picture. If you have a machine now that can read the letter and understand, yes, that's Florian. Yes, I can find his policy ID and customer number. And yes, this picture actually shows a broken window. And he claims this is 250 francs. I pay this out. And the insurance could be a smart contract in the same way. And my claim to it is I write an event with supporting by certain evidence and a letter. On the other hand, you have a machine who can read my letter, can understand the evidence, the picture, and then decide to pay on that. And this is where you said the two words come in. Contracts or smart contracts is the way to execute transactions, to agree on transaction and execute transaction. And then other technologies that come from the machine learning and AI domain is understanding unstructured information that previously only humans could do it. So human handlers were reading letters and looking at pictures. Now a machine can do it, or can machine prepare it. And then the machine actually starts to write structured data. It writes an event and says, I accept the claim. And the other event is I will pay out the sum that is asked for example, in my home insurance example. So this is where we are moving.
Yeah. So that's really exciting. I mean, I think insurance is actually a really good example. I was doing some work with an insurance company actually over in Europe, and they were describing some new offerings and some of the things they're working towards, and they kind of laid out this scenario where I'm driving to the airport because I have a meeting to get to in London, and I on the way to the airport, I might decide that I want to buy some flight insurance that says that if I land, 3 hours later than scheduled, then I get a payout because I'm putting a hedge against my tardiness because there's an economic cost of me being late. And then I arrive at the airport and the GPS device in my car recognizes that it's parked in the airport parking lot and that I've got some sort of ticket for an airplane. And so it reallocates part of my vehicle's insurance policy to my travel insurance because, the risk to my car is extremely low in a parking lot in an airport. And so it's being dynamically allocated. And all this happens kind of, magically, that there's these contracts that have all these conditions. We don't have, insurance personnel that are processing all these policies and then paying out the claims. It's just all kind of automatic. And then on top of that, you've got all of the parametric examples of, people getting crop insurance in, Ethiopia, and satellite images being used to determine the color of the grasslands to infer the viability of the cattle stock that's being insured. And once again, it's just all algorithmic. It's automated. The application, the risk assessment, the claims payment. That seems to me, something's taken an awful lot of cost out of the whole equation. Am I wrong on that?
No, I think, as you said, the more we would get to, for example, insurance contracts that work on clear parameters that a machine can measure and provide. And for example, in your airline example, this is an interesting example because you have the guy who takes out the policy, you have the airline that actually sort of notifies its arrival of planes and being late or not late to some public register, and you have the insurance company that then pays or doesn't pay, depending on if the airline is on time or delayed. And this is already a three-party problem. And where I'm coming from is I think we need to correctly specify what is sort of the contractual basis. So what do we agree on? And then how does the contract get executed? And I think here the problem of classic public blockchains, think about Ethereum, is everything is in the blockchain. And that's why it got stuck. It got stuck to the domain of assets and asset transfers, because there you have all the data and all the evidence within this one platform. It's very convenient, it's very powerful, but leaving sort of that one platform where you go to another source of evidence, for example, the satellite pictures and some technology needs to acknowledge if the color is green or brown in order to pay out the crop insurance or not, is usually out such a platform because a platform cannot engineer all these possible cases. It is too vast because you were thinking about a crop insurance and I was thinking about home insurance. They need totally different ways of getting the data, getting the evidence in. And that's why I still believe very strongly we need one basis just to agree on contracts, the rule sets, and the evidence of the rule set. In the case you break the contract, I pay you the money. There is tamper-proof evidence the plane was late because there's Heathrow Airport writes down the arrival of the planes, and then no payment comes. Because if I know you as a party, I need to then go to a court or sue you because I said I paid you the money, the conditions of payout were fulfilled, the plane was 3 hours or more late, I want now £500, and there's no payment of you. Because if this all comes to the same platform, there's another problem. If you have everything in the same platform, you need to collateralize everything. Because in order to make sure that the contract actually gets executed, then you need to lock in the £500. You need to pay me in the case the plane is late. And in the case it isn't, you can withdraw it. But that would cost you a lot of capital as an insurance company if you would need to provide the capital for all potential claims ahead, that would be too capital intensive. So that's why a real contract is a promise. It's a promise. And then you have to provide evidence if the promise was kept or not. And I think digitally, we need to move to something else, because if everything needs to be collateralized in order to make sure that it actually gets paid, and this is the way how Ethereum works. In Ethereum, if there's an asset against money Ether transfer, you know the other guy has the asset and you have the Ether and gets locked in, but that's a short-term transaction. But if I make a long-term insurance contract and there's a lot of capital involved, because I don't know, I'm insuring my factory in Switzerland, which I don't have, and potentially if the factory burns down, you need to pay me 20 million. That would be a lot of capital you need to lock in such a contract that it actually gets executed. So that's why digitizing normal contracts, making sure that I know you and me have a contract, but without sort of the need to lock funds and everything, is already a way forward and would create enormous potential in automation, because the two sides at least know which rule set they're engaged in and which data and evidence is provided.
So this is very interesting because, you know, I've always thought, and I guess I'm guilty of the short-term thinking, that a lot of the potential here is that funds are in escrow, and that protects me from a renege problem, right? That they're in escrow, yes. And if I do what I'm contracted to do, then the escrow is released to me, and you know, everything's great, and that means that you can't just renege and not pay me, and that's the power of it. But the point you're on, I mean, the insurance industry globally has something like $24 trillion under assets that they've collected from, you know, policyholders that represents, you know, some potential amount of claim is up against that. But locking all of those funds into escrowed wallets to guarantee the potential payout should a claim be made is just completely unfeasible, right? It actually breaks the entire insurance model. So this is a really interesting idea.
They would vastly need more capital than they have today, because insurance is also coming now from Switzerland, where a bank almost went under. Insurance is in a way fractional damage reserving, because not everybody has the claim. It's a bit better than banking, but you're making a similar bet that there's no systemic problem, that not all the houses burn down in the neighborhoods you're living. And with fire insurance, there's a very good assumption. But sometimes this also goes wrong, for example, in certain natural disasters. And that's why you need also reinsurance, another layer that diversifies such local systemic problems. And because of this, finance, essential normal finance, normal banking, normal insurance is promise contracts. And I think you cannot move towards this full certainty securing payouts or securing funds, because then you break this diversification or this fractionalization, sort of feature that modern banking or modern insurance has. And we haven't found much better, to be honest. And it has a lot of problems. See what's going on with US banks, see on what's going on with Switzerland. Insurance companies also go broke. I think securing that is probably almost impossible. But But automating it and making it more efficient, and especially insurance, doesn't strike me as very efficient. Insurance businesses tend to be still very human, paper or process-driven organizations.
Okay, so if it's unrealistic for smart contracts to literally hold assets in escrow for conditional payment, and there still is a lot of value in putting capital to productive use, right? Even if it is promised to a transaction. If we're really in that situation, then we have to find some sort of hybrid, because
yes,
if we don't find a hybrid, then we're left with the system we already have. So you've got a contract that promises stuff, and that it might have code in it that automatically executes the transfer of funds from this wallet to that wallet on when a condition is achieved. That's great. But then it would suggest that you need to have some logic in it that ensures that that wallet at least has a reasonable reserve to be able to reasonably address the anticipated or potential claims against that amount of funds. And I suppose this is actually one of the areas where AI might come into play as well, that figuring out what the odds are, making predictions about that and predicting how much buffer you want in the system, all becomes part of the ultimate solution. Am I going down the right road on this? Or
yeah, I think so. I think one of the huge problems we have actually with that regulation works is this information lag or this intransparency problem. If you would have a smart contract against whatever the money you put down to a bank or the fire insurance I take out, but the same contract would give me certain information like how many loans did they, how much money did they take in, and it would provide radical transparency. I, as a client, would see, damn, this insurance is writing too many policy against its capital. I would need more capital. And instead of moving this job to a regulator who moves the job again to some auditor who sometimes look at it, if you have a configuration where the information exchange between my smart contract and, let's say, the deposits or the capital they allocate, as well as all the other contracts they're doing, I would immediately see this is not a very safe insurance, or this is a highly levered bank, and so on, and I can make a decision to withdraw and not take out an insurance. And we wouldn't need this arcane regulatory structure that more often fails than works. Because if we're honest, the way we regulate financial services is a disaster. Switzerland, Credit Suisse just went under. It was rescued by UBS, but essentially went under, and the government took a 10 billion guarantee to it and put 200 billion in loans in. But we had a full regulation called Too Big to Fail, where supposedly no bank should ever be rescued in Switzerland. And if you read the regulation, it was so abstract and so legalistic. I always thought if it comes to that point, it will never work, and there will be always the same type of bail-ins where people get angry. But why aren't our clients more careful with banks, or why do we have to sort of relate to such structures? Is the transparency problem. Because if I take out a smart contract and I see this thing is highly levered, I may not do that. Or by getting out this contract and I see immediately the information, sort of the asset liability side of the insurance or the bank, I would say, no, I'm not going to put any money in here because that's a too levered institution. Or yeah, it's a fine institution. It has just Swiss mortgages and its equity in the mortgages is great and so on. So that's a fairly safe institution. But no banking client, no insurance client has any view on the transparency, and has also no way that such a smart contract would give you, let's say, an immediate rating, and the rating changes all the time because it has all the information. And that's another reason I think why classical institutions are fighting this, because they're actually making an information arbitrage all the time, because you as a client taking out whatever business you do have so little information vis-a-vis the organization itself and vis-a-vis also the regulator, because they're essentially still intransparent. And I think this is where a lot of the potential of smart contracts in its information potential and its exchange and automatic rules is somehow completely missed. And maybe the class, especially banks, still wouldn't want to do this at the moment. I see that, but
it's interesting.
Me as a client, I would like to have a bank that gives me this type of transparency. Maybe I'm a nerd, but
well, I recall a number of years ago, I was having a meeting with the president of a very large insurance company, and I'm sitting in the boardroom waiting to meet him. I'd never met him before, and he walks into the room, and before we shake hands, before there's any introductions, before there's any kind of context setting, the very first words out of his mouth is that my industry hasn't substantively innovated for over 35 years. There's a train coming at me at 100 kilometers an hour, and I'm terrified, right? That was the opening statement. And I thought it was a rather succinct, kind of summation of where we are. And you've been describing some of the, implicitly some of the attitudes of conservatism, the way things have been done. And I think part of that kind of goes to your too big to fail issue, is that tinkering with these systems is dangerous, right? That if you get it wrong, if you mess it up, then really bad things happen, right? There's contagions that can run across the entire economy and cause all kinds of mischief and hardship. So, I've been kind of thinking through it, and the case of insurance is a very interesting case. What's it going to take to grab an industry and kind of shake it out of its complacency and get it to move forward, because there's so much potential kind of sitting there. And, we're talking today about two of those things. We've talked about smart contracts, but let's kind of talk about the other side of that equation. So AI, and we've briefly kind of touched on it, but so much of the insurance industry today is paper-based and is based on unstructured data. So if I'm correct, a lot of the work you guys are doing at DGTAL is about unleashing the potential of all of that unstructured information, because once you've analyzed it, first of all, you get insight, but second of all, you open the door to potentially automating processes. So how do you see, what are the big areas where AI can be applied to the insurance industry?
I think there's a case to be made why both concepts create sort of real-time analyzable data and sort of calculation on, if this happens, what happens then? Regardless if you talk about a paper contract or you talk about documents that describe, for example, claims and accidents, if the stuff is not correctly digitized, i.e., a computer can read it and can count it, you have humans who put in numbers, and they often just put in a number, the value of a contract or the value of a claim, but they have no further look through it. They have no further attribution on why. And at the point you start to have not only values, but the reasons why, and this goes a bit to the smart contract side, if this happens, that happens, that provides you immediately the ability to analyze, scenario analysis and so on. You actually have no real look through or no clue, in a way, why you're facing a certain liability, why you're facing a certain scenario. And this hinders also risk management, because you cannot run scenario analysis, because you don't know how much of your damages come from this type of accidents or that type of accidents. And there's an example in 2021, there was a huge flooding event in Germany. And most of the insurance had no clue how much exposure they had, because they had to really look, where were the houses, are there cars in that area? So they actually went to auditing firms who went through all their policies and already the first claims in manual work as an enormous amount to correctly report the exposure to this enormous flooding event. And that took them half a year. And while the accountants were working on that, already the claims came in. So the claims came in faster than they actually finished their exposure calculations. And this shows the problem. This shows the problem that by not understanding your unstructured data, your paper data, either be it claims or contracts, you cannot analyze what is happening now, and you can also not run scenarios going forward. And then you cannot do risk management. You can do it on a very, very high level, lump sum level, but not on a detail level. And then because if you can't measure certain things, you can't manage it. And that's why I think also on the banking example we had before, not knowing your exposures, and banks have a problem. Banks often don't know their exposure, and regulators then don't know the exposure because everything is aggregated. You don't know the details. Getting to the details takes you so long. And here comes the power of both elements. AI is turning your documents and picture in data that a computer can calculate and account for. But the same, if you move from a paper contract to a smart contract, you first of all have data the machine can read, and you have an analysis. If this happens, the contract says we shall do that. And this is both a much denser set of data, and not only unstructured information and real-time information, immediately being able to calculate something, and then maybe empowering you still to act on something, do preventive measures that reduces damages, taking out a hedge somewhere. But if you don't have this information, you can actually not act. It takes you all the time just to gather information, make sense of it, and then often sort of the house is burning. The problem is there, and there's nothing to be managed. There's only then to be paid. And I think this is where also those technologies play such a role together.
Okay, so I think that's an important observation that technologies, do play together, and that as we transition to the Web3 era, there may be some mutual reinforcing, right? That I've always thought of, AI is impacting our lives in a whole bunch of ways, right? Everyone's kind of enamored or mystified or scared of ChatGPT and its kind of very spooky emulation of general intelligence. But when we really boil everything down, there are applications of AI that let us do things, right? It lets us to do natural language processing and to, understand, content and be able to process, large amounts of documentation and make sense of them. I think that's all right. But what it really boils down to is prediction, right? So the impact that AI is going to have in the Web3 era is that prediction will become a basic inherent characteristic of almost everything we do, right? That every transaction we engage in will not only have the transacted variables, but will have a predictive context that says that, this is the outcome that should be expected. And there's some AI engine in the background that's doing a whole bunch of analysis based on all kinds of other histories and input from lots of IoT devices and whatever. And it's saying that, that this is the outcome. And whether this is a traffic pattern, or this is a weather pattern, or whether this is a flow of goods pattern, and or it could be a composite of lots of problems that, if you've got a weather in the Atlantic Ocean that's affecting shipping, that's going to cause a backup in in one of the ports in Rotterdam, and that there's a density that's going to cause a lag of processing through the customs agents or whatever. But understanding the prediction of how all of those systems interact with each other is as a pervasive element of how we interact with systems. That's pretty disruptive, right? It sounds to me, I think that's a big deal. Is that wrong?
No. And also going a bit back to this interaction between prediction and smart contracts. If you have contracts and if they do that, you do this, this is like giving the computer the chess rules. And before, you have to predict basically on your past behavior. But as an organization, I have a lot of outstanding contracts. And now I can tell the computer, this is the chess rules, because if we do this or do that, they will do that, because I can, for example, default on a contract, because paying the penalty is much easier because somebody else is paying for the same goods now, much higher price. So I default here, give the goods somebody, get money in here, and also sort of doing a new contract, adding a rule to the set. Now then the computer, because the power of computer and the power of machine learning now allows you to play through all the rules, like playing a Go game. But before, when you don't have the rule set digitized, you have to guess the rule set and the actions of the other guys, your actions, and come to some conclusion. And then this is very, very hard. And that's why people don't do it. But if you now have the rule set, you know how the game is played, because that's your contract. That's how you agreed to play with your opponents. Then you have past behavior that helps you to inform on decisions. Then you have the state of the world, your IoT devices saying, where are your containers, where's your stuff, where's your where. So you sort of have a near casting, you know where you are. And now you can make the best business decisions, including things like I default on a contract, because it's just a rule set. I don't deliver and make a payment. I deliver here, I take out more contracts here because the Americans pay now so much higher prices because their inflation is so much higher. And I renege on my obligations to deliver to European clients because they don't have as much money as the Americans with their flood of money now. And this is where the things all come together. The one set of AI technologies allow me, first of all, to know where we are, understanding documents, understanding the unstructured stuff. The smart contract is the rule set, sort of the chessboard I'm playing on. And then I can use all this analytical power, all this enormous calculation power we have. And this is also what people tend to forget. All the GPU power that enables AI can be used to just simulate vast amount of my chessboard. And it comes at so low costs now that, and I think that's what, for example, a lot of companies have not thought through, that they can do this. And also how I can enable other parties to play with me by outsourcing things because the rule set is clear.
So you just said something I just think is absolutely fascinating, because, and I'm kind of inferring this, but we'll get to it in a second. You mentioned, well, two things that I had kind of thought through, right? One was the question that if we do have pervasive prediction about all kinds of situational variables, that those in fact are potential inputs into smart contract logic, right? That you can have logic says, if the prediction engine is predicting this, then do the following things and trigger this.
Yes.
And that kind of stops us from being reactive and allows us to be much more proactive. And there's all kinds of systems that proactiveness might apply to. So, that's something I have thought about and I think is kind of cool. The second thing that I just thought about as we were engaged in the previous part of the discussion about the escrow problem and the reality that you can't lock away all the funds, that AI can make certain kinds of predictions about what a reasonable and buffered amount of escrow would be, and that logic can kind of be embedded into the whole system. So that's another interesting application. But the third one that I hadn't thought about, that I'm inferring from what you said, that I think is really interesting, is that your description of AI kind of knowing the rules because of its experience and its processing of so much data that has been historically happened, that it might be a tool that we can use to help write high quality smart contracts, right? I mean, can we use the insight we get from AI, or for that matter, even generative engines like ChatGPT, to write high quality, context sensitive smart contracts such that the automation in a system like in the insurance industry would work really well, or as well as possible? Am I going too far out on that branch, or is that?
No. I think if you can start predicting, especially in scenarios, historically it would happen, this happens, this happened, then happens. Now you can start to
So we should put that in the smart contract.
Good rules that, yes. What would be good rule sets or amounts of escrow that protect me, but they're still economically fair. That is still an economic fair price where two parties will agree on this exchange. Because if you have researched not only ChatGTP, but the technology behind it and the wider APIs, there's an aspect that this thing can write you code. You can describe a situation and it writes you code. So you can also describe business outcomes and outcomes you don't want. And it can put them into real logic in a smart contract or in any type of logical code, in any logical formalism. And this is possible, especially if you think about using this based on the wider scenario analysis, not just a simple thing, if then this. Because the complicated things we as humans tend to miss is combination of things where we never thought that this part of the tree we would traverse. And this often needs something like simulation, exploration, and so on, because just by logical thinking about it, we miss it. And anyway, a lot of lawyers miss that. They never think about that the clauses in their contract could lead you to a certain situation. That's what now often happens with Deon. We formalize something, and then we simulate it, and we see there's passes you can go down, nobody thought about, and nobody actually wanted. On both sides.
This is a really interesting idea, and I'm quite amazed that I actually haven't run into some brilliant startup company that's doing this. I suspect there is one somewhere. I just haven't seen them yet. But I like, I'm sure a lot of people have been amazed at seeing examples of how some of these ChatGPT and similar engines are generating code, right? And programmers are using them to dramatically improve their productivity. This idea that they could, not only write a functional smart contract and write the code for it, but incorporate all of the insight they may have because of a legal context or a jurisdiction or an industry, and incorporate those specific elements so that you have a highly productive, high functioning, high quality smart contract. And the cost and ease, the cost falls dramatically in the ease with which you can build these things, just improves so much that, maybe we're going to end up in a situation where these technologies are just so pervasive, so inexpensive, and provide so much extra productivity that we reach that inflection point where that they end up being the catalyst that really propel us towards the Web3 world. Is that too utopian, or do you think what time frame do you think we get there in?
I mean, given the speed how things work, and they work actually faster than we tend to think linear, but the world is exponential. Could be in 4 or 5 years, 3 years. I started to look into this large language processing in 2019, 2020, but the way it has progressed to 2022 is phenomenal. And the quality of language generation, it is still not general intelligence. It makes a lot of logical flaws. But what people also tend to underestimate is the quality of analysis of language. People are just using and chatting and creating language. But what very few people do is actually put context documents and then start queries on it. It's a perfect query engine. And if you can query something and it starts to have a longer memory, you can put in a lot of sort of past experience, past events, what happens, and then you can start to query it, and then it can tell you this happened because of this, and this, and in order to prevent it, now you can come back to there's a rule set that would have prevented it. And I think that's possible. If you talk about I don't know, GTP4, how many parameter it has, it's rumored to have another.
Well, I think that the processing set is being increased from 4,000 to 25,000, which is pretty big.
Yeah, but the actual parameter of the network is from 175 billion to 100 trillion rumored.
Wow. Okay, well that's a whole other episode of W3B Talks, but that's a fascinating topic. So just to kind of summarize things, we started this conversation by talking about the potential of automation and how automation is the glue that allows processes between various different economic actors to be coordinated extremely efficiently. And that if we can solve that problem, then the ability to assemble, different pieces of an economic model and put them together and reconfigure them and just, do lots of interesting, innovative things incredibly efficiently, that really is the basis of the Web3 world, and it's what's really so exciting about this. And we talked about smart contracts and both the power and some of the deficiencies in the kind of existing model and how AI is intersecting with that. Any other, is there a third piece of this puzzle that we need to make it all work? Or do you really think that the next era is going to be sufficiently, fed by smart contracts and AI as the energy source for intercompany process coordination?
I think the last puzzle is us humans to actually make this leap forward and sort of accept it and go this way. Because what this would do, it takes away all the boring processing part. It takes about sort of the automation in transaction. It doesn't take away humans to think about which businesses they want, how they want to engage. And in the same way that in physical production, more things are done by robots, but still you need designers to design new cars and think about new products. I think we need to move forward to get away this boring bureaucracy, this automation, this hand processing layer between companies. This goes to the AI. And humans then do something different. They think about new businesses, but they also think about how humans explain what the machine does to other humans. So in a future insurance, a claims handler is not handling claims. It's just explaining why the thing is and why that's a fair decision and so on, and talks to humans and takes care of humans, because that's actually where we are much better at. We're much better at the human-human interaction than interacting actually with text or interacting with abstract things, because we're actually pretty bad with abstract things. And that's why I think the human equation is the thing what is missing, and where we need to educate ourselves and really being open to this potential. And as in any other industrial revolution, it will not take away a lot of jobs. I think rather to the contrary, especially the European situation is with so many people leaving the job market and being retired, we will need every damn automation in order to run the services we are expecting from companies and the state and so on. And we should rather automate the boring bureaucratic stuff and then have the humans to take care of humans and being creative, enhancing technologies, and do that, than processing boring claims or executing boring transactions.
Well, I think thank you for that. That's some really valuable food for thought. And I think it's a great place to both end this conversation as well as to start some other really interesting conversations. So perhaps we'll have an opportunity to revisit this, because what you just said, I think is a great place to start some really important conversations that could lead us to some interesting insight. But thank you so much, Florian, for joining us today and sharing your thoughts about how smart contracts and AI will impact automation. And thank you all for joining us for this episode of W3B Talks. You can find out more information about Deon Digital at deondigital.com and DGTAL at dgtal.io. You can also find more research on this and many other topics at blockchainresearchinstitute.org. I'm your host, Doug Heinzman. We hope you'll join us for our next episode of W3B Talks.